Okay, what we're going to do now is we're going to calculate the volume and the surface area of the following rectangular pyramid. First thing I'm going to do is I'm going to calculate this guy's volume. Now, I look at my rectangular pyramid. Obviously, the base is a rectangle. It's 15 by 25, and the pyramid has a height of 8 feet. The formula that I use to calculate the volume of any pyramid is 1/3 times capital case B times lowercase h. What this stands for, the capital case B represents the area of the base. Not 15, not 25, the area of the actual shape, whatever the base is. Sometimes it's a triangle, it can have different shapes. A rectangle, a square, this one's a rectangle. It's 15 by 25. So capital case B would be the area of that. 15 times 25 will give me 375, but we'll get to that in a second. The lowercase h represents the height of the pyramid itself, from peak to base, perpendicular. All right? And that comes out to be 8 feet. So now what I do is I substitute the values in for each of my variables. So now what I get is I get 1/3 times 375, which is 15 times 25, and last but not least times 8. And then when I'm all said and done, I get my answer to the problem. The volume of this rectangular pyramid is 1,000 feet cubed. Piece of cake. The trick is knowing the height and knowing what the shape of the base is and the dimensions. That is how you calculate the volume of every rectangular pyramid, or every pyramid in particular. The next piece is the surface area. I apologize now. It's not necessarily as easy as the last. When you calculate the surface area of any shape, you're basically calculating the area of each individual face, a region you could touch. Imagine you could take this picture, pick it up. Every single region that you can touch as you rotate this thing around is an area that you need to calculate. This pyramid has 5 faces. It has a rectangle on the bottom, and it has 4 triangles around the top. Now, your triangles have special properties. The properties of the triangle have the same basic characteristics as the bottom, the base. Since the base is a rectangle, what we know about rectangles is this. This is what we know. We know that this side of a rectangle is the same as this side. Makes sense, right? As a result, that means that this triangle right here is exactly the same as this triangle on the other side right there. They're identical. So when you find the area of one of them, all you have to do is double it to get the total area. And vice versa, to ditch this right here, doing the same exact thing, if I know the dimension of this is 15, then I know back here is 15, that means, because it's a rectangle, that this triangular face in front is exactly the same as the triangular face in the back. They also have exactly the same area. So now I take the area of that one, the front, and then I would double it to have both the area of the front and the back. So now, when I do this, piece by piece, step by step, what I need to have is I need to find the area of the triangles. To do this, I need the triangle slant height. No ifs, ands, or buts about it. And right now in this math problem, I do not know the slant height. They're missing dimensions. So to find those missing dimensions, what I need to do is I need to use the Pythagorean theorem. A squared plus b squared equals c squared. It's a common task that we did a little while ago in math. So we've got to rely on our prior knowledge to do so. And what I need to do is to find this right here. To find the area of this triangle. I know the base. The base of that triangle is 25. To find the area of a triangle, I take the base of it times the height of it, and then what I need to do is divide it by 2, or simply 1/2 times the base times the height. But what I need is I need this dimension right here. I need the distance from the peak of the pyramid diagonally down to the center of that side, that bottom part of that base right there on that right-hand side of my pyramid. I need to know that length. And the only way I can find that is by building a cross-section of a right triangle using this pyramid inside of it. The right triangle I'm talking about is the one I'm going to highlight for you in green here. I'm going to use the height of the overall pyramid. I'm going to use the slant height, which I'm trying to find. And last but not least, the base is going to be the distance from the bottom of the height to the slant height, the bottom of the slant height that I just formed. Now, my formula, Pythagorean theorem, walking you through this step by step. According to my calculations, I'm going to get a slant height of 10.97. I do this simply by the following. The two legs of my triangle are the height of the pyramid, which is 8, and the other leg is represented by half the distance of the base. You see, this measurement right here, down on the bottom of the bottom of the pyramid, this right triangle, is exactly the same as half of the distance from here to here. And half of 15 is 7.5 right here. So now, 8 to the second power plus 7.5 to the second power is going to give me 120.25. And when I take the square root of that, I get this value. And that value right there is the height of my triangular face. And once I know the height of that triangular face, I take the base of it times the height divided by 2, or 1/2 times the base times the height, and I get the area of that face. And then what I can simply do is double it, because that would be the area of the left face as well. Now, we're still not done, because what I've just done right there, what I've done is I've only found the slant height of the left and right face. What I need to do is the Pythagorean theorem basically all over again. I need to calculate the slant height for the triangle in the front and the triangle in the back. And that's the only way I'm going to be able to do this. So now, I'm going to do the exact same step. My triangle is going to have a height of 8 feet. My base of my triangle is going to be half the distance of this, 25, which is 12.5. And what I need to find is I need to find this, the distance from here to here. That's missing. That will be the height of my triangular face in the front and in the back. So now, when I do my Pythagorean theorem and I build this triangle, and I have this whole thing over here for you, I'm going to move this piece by piece. Unfortunately, it wasn't real nice for us. Didn't paste exactly the way I wanted it to paste, but we'll adapt. And all these little pieces, same way, just like before. Exactly like before. Step by step, right here, 8 times 8, this measurement there. And I have this one right here, half the distance of 25, which is 12.5, 12.5 times 12.5. Add them together, I get 220.25. Take the square root of that guy, and then what I get, 14.84. The distance of my slant height of the pyramid, which is basically the height of my triangular face in front. Wow. Primarily what all that is. When I go to this, calculating the area of the triangles, explaining and putting all these pieces together. So now my two triangles, after calculating the slant heights, 10.97 and 14.84 for each of these triangles, and having a base of 25 and 15 respectively. And remember, left and right face, front and back face. My formulas are down below here. Notice the red times 2 on each of the formulas right here, representing the fact that I have to multiply it by 2 because of the front and back, left and right. The areas of each of the combined regions that I have, 274.25 and 222.6. The next piece represents the area of the rectangular bottom, which is 25 by 15. 25 times 15 makes 375 feet squared. And last but not least, I combine them all together. 274.25 plus 222.6 plus 375 combined together to make a grand total of 871.85 feet squared. This is the surface area of this rectangular pyramid. I hope you found this helpful, and you have any questions, bring them on in tomorrow in class.